today we got a special event. Today we're going to talk about the ecosystem fuzzing, which is something we've been looking into. Fundamentally at Recon, we want to eventually write invariants for everything. And there's basically two theories. There's two theses that you can have when it comes to writing properties. And one of them is that you would invest in AI. You will invest in AI for automated property generation. You would invest in that. There's nothing wrong with it. I think it's a viable alternative. It's just that my current perspective on it is that that's what we are doing as security researcher. That's what makes us humans. That's what we haven't been able to capture. I think if we were able to always write a test that will prevent an exploit, we wouldn't have any exploit. So that's why I think the AI aspect is not a silver bullet. It's just going to be one of the many techniques. And so our stance is instead to have people fundamentally understand core state transitions. And then from those state transitions, we can then write testers that either test for specific aspects, which is something we're going to be testing soon with Uniswap v4, or they can simply help you explore the most important state transitions. So that's what we're going to talk about today. I'm going to briefly share my screen, and then we're going to have Nicanor, our fuzzing engineer, who led these development, talk about the code bases, talk about the coverage, etc. I'm going to do just a quick intro. And before I do that, as I share my screen, so let me know if you can't see anything, I just want to give a quick shout out to a new feature that we got on Recon. So this is our usual Recon app, and Recon helps you set up CI/CD for invariant tests in the cloud. And so the latest release of our job page features a new mode for Echidna, which is the fork mode. So previous to that, we had to set up a arbitrary command, basically a command that we could only run. But as of today, through Recon Pro, you can set up fork testing in literally one click, which allows you to also specify, you can see here the block number, whether you want latest or whatever block which you want. And obviously, thanks to the power of recipes and our automation, you can set up a fork tester even on PR. And a good example of that will be when you want to test something like a router, when you want to test something that is fundamentally forked in nature, where it just doesn't make sense to have tens of mocks or to use another technique, which will be the factory technique. So this is going to be there's going to be two repos that we're going to talk about today. One of them is called Eigenlayer Fuzzing, and the other one is called Renzo Fuzzing. Fundamentally, Eigenlayer Fuzzing allows you in literally one line to import the Eigenlayer system and basically use the Eigenlayer system as part of your own fuzz tests to build your own fuzzing campaign. And that's what we're going to see in the Renzo code base. And what obviously what Eigenlayer is, it's basically a way to restake your token. Basically, you will deposit either staking derivatives or pure ETH, and then Eigenlayer would effectively rehypothecate that through its own strategies. So in terms of our code, at the end of the day, we don't have a massive surface area. You can see that our tests are going to be here at test Recon. And we fundamentally will have just a few extra contracts that allow to spin up, obviously, the tens of contracts that are part of Eigenlayer. So this can help you simply set those up. And then at the same time, the tester will effectively look for the interesting aspects of the Eigenlayer system, which will be depositing, interacting with it, and fundamentally slashing it. So by starting with something like this, instead of having to start from scratch and not knowing how to set up your invariant test, you can instead fork from our open source setup, and basically you can get to a point where you're going to have a high level of coverage by default, so that you don't have to focus on coverage, because to us coverage is a means to an end, and you can just focus on properties, which is what you will do in your own implementation. In this case, we have the Renzo fuzzing example, but fundamentally in your own implementation, you will then focus on the properties, which as of today, we consider tightly coupled with your system. We consider a fundamentally human aspect, again, because of what I said before. And so fundamentally, that's what you will want to do. So without further ado, Nicanor has spent quite a considerable amount of time setting up the system. So I'm gonna stop sharing my screen and I'm gonna have Nicanor show his thoughts and give us a tour of the code base. Thank you, Nicanor.
Thank you, Alex. You should be seeing my screen now.
Yeah, looks good.
Correct. Cool. Okay. So, yeah. So as Alex said, it spent a while getting this set up, and learned a lot in the process about just what you're actually looking for when you're setting things up, keeping things as simple as possible, and hopefully some of that can come through with this. So essentially what the primary thing that we have here and that gives us the entire Eigenlayer system is our deploy Eigenlayer local function. And then this, sorry, I got some weird sounds from Discord. So then we can essentially just inherit from this. We just inherit from this Eigenlayer setup contract into our Eigenlayer system. So then this, for integrating protocols, this is the key thing that this repo basically gives you is it gives you this /native and /AVS out of the box. So you can simulate those types of events with your fuzzing setup without having to do any extra setup on your own. So /native kind of probably pretty well known, but it just simulates a slashing event of native ETH that would happen to a validator that is opened through Eigenlayer. And so that just essentially uses this fuzzing ETH deposit mod contract, and so it just decreases your validator's stake, and then also accounts for their balance update using this, because this is how user or validator balances are tracked in Eigenlayer, is through this Eigenpod manager. So then the thing that's particular to Eigenlayer specifically is that you have AVSs are the primary service that Eigenlayer offers. Is so essentially you get restake tokens offer security services for protocols building on top of the Eigenlayer, but so in that you can to be able to use your restaking tokens to offer those services, you can either deposit native ETH or some sort of LST like ST ETH from Lido, and that will create a balance for you in this either Eigenpod manager if it's native ETH or strategy manager if it's an LST. And so then because these the way Eigenlayer works is essentially you would, after having deposited made one of these deposits, then you would delegate. You can delegate yourself, or you can delegate to another account. To use these restake tokens to provide security somewhere. And so essentially these secondary types of validator, these secondary operators are expected to behave in the Eigenlayer system appropriately, essentially. And so if they end up not behaving appropriately, acting maliciously, Eigenlayer's system allows slashing of the these operators. So, and currently the current Eigenlayer system doesn't have an actual implementation of their slasher contract because it hasn't been released yet. So this was kind of based on inferring from just kind of basic logic of how a slashing event would probably take place. We'll probably update it in the future as Eigenlayer does actually release their real slashing contract, but essentially it's the same as above. So you just, if the operator has native ETH staked, their stake gets removed from the ETH deposit contract, and then accounting is updated. And then if they have LSTs, their LSTs get, just for simplicity purposes, burned. And in this case, burning is just sending to this random address. And then also have their balance in the strategy manager accounted for. So yeah, those are the primary utilities that we get from this Eigenlayer system that make fuzzing integrations with it significantly simpler. So then when we go on to something like Renzo, which is a protocol built on top of Eigenlayer, which essentially just simplifies the restaking process, and instead of having to worry about your own managing your own allocations that you set to different operators, it just uses what they call operator delegators. And so it essentially just you deposit into Renzo and everything is taken abstracted away from you. You don't have to worry about operator you're delegating to, and it's kind of all handled for you. So then in the Renzo case, we can just, for our setup, we just have this Renzo setup, which we inherit Eigenlayer system from.
Sorry to interrupt you. As far as I can tell, I'm only seeing the Eigenlayer system.
Okay. Okay, let's see. Okay, are we seeing Renzo now?
Yep, I see Renzo setup now. And please do repeat how to set up the Eigenlayer system within Renzo so that people can also see it in the code, please.
Yeah, sounds good. Yeah, so to set up Eigenlayer within Renzo, we essentially just inherit from Eigenlayer system. To be able to get our Eigenlayer system, we add the Eigenlayer fuzzing as a submodule dependency, since this is a Foundry project. So it's just, it's here in the README, but it's just essentially forge install, and you provide the forge install Eigenlayer fuzzing, and then you have everything from the Eigenlayer fuzzing repo available to you. And so then to actually implement that into your integrating protocols setup, you just inherit from Eigenlayer system, and you just call this deploy Eigenlayer local, and then you have everything from all contracts from Eigenlayer available to you. So you can directly call them if for some reason you would need to in your fuzzing setup, or you can just use them or have them integrated to your actual integrating protocols setup. So would have can't find a good example, but like these tokens are deployed from the Eigenlayer side. So you already have that, and these specifically in the Eigenlayer deployment already set up token strategies on Eigenlayer, so you can directly access those and set them as needed here. Yeah, so then after we call deploy Eigenlayer local, then we call the deploy Renzo setup, which is basically just everything that sets up our Renzo system. And then the primary thing that we care about for fuzzing, and in this example, so we have our restake manager is the primary entry point in Renzo, where basically everything happens and what you would interact with. So then we have all of these as target functions exposed here, and the primary things of interest where we use things from Eigenlayer is this here, this restake manager /native. So we see that since we inherited from Eigenlayer system, we can just call this /native function, and that allows the fuzzer to simulate a native slashing event just in one line of code essentially. And so you kind of can get a better, it allows your fuzzer to kind of explore a larger set of possibilities and possible edge cases that that are usually a lot of times can end up being left out. So then we just have the same thing here with /AVS. And then specifically for this setup for Renzo, I also implemented this LSD discounting and LSD rebasing functions. So they essentially just allow the fuzzer to manipulate the price of LST tokens and kind of let us see if we can break any invariance. If for some reason LST tokens kind of lose their peg, which historically has happened with things like STE, not significantly, but it's still a cool way to be able to kind of explore those kinds of edge cases. And then rebasing is obviously a much more common thing for LSTs because that's kind of how they accumulate their value as they earn staking rewards. So in Renzo, all we really care about for LST rebasing is the price of the token. So this also just manipulates the token price. And yeah, that is pretty much it. If there's any questions, happy to answer. Alex, if there's anything else.
Yeah, Nicanor, let's go over the coverage report. Let's give some thoughts around what a theoretical integrator would have to do. And also let's talk about some of the insights when it comes to clamping versus sorry, Renzo, please please mute. So what was the yeah, let's look at the coverage report, please. And I think we're gonna have the same issue with the sharing, so you may have to disable, re-enable the screen. And then let's also talk about some of those ideas when it comes to clamping the strategy, clamping the tokens, clamping the AVS. Let's hear some insights when it comes to having more actors. So this is the coverage report, right?
Yeah. Yeah, this is the coverage report for Restake Manager. And yeah, so the primary thing that came up pretty early on in this this project was essentially the fact that we have a lot of these calls to target functions within within Restake Manager that use things like specific amounts or specific token values. Like here for deposit, we pass in a specific collateral token. So pretty early on, kind of ended up facing a lot of coverage blockers because I had just been leaving these unclamped and just ended up getting essentially with any even extended run wouldn't get past one of these deposit calls, so wouldn't really even be able to start looking at the system in any sort of interesting state. And that's essentially just because of the fact that if you're passing in addresses like here for token addresses, you're gonna, if you leave that unclamped, you just end up exploring the entire state space of addresses, which is incredibly large. And so it kind of, this is something that me and Alex discussed a lot, but it was just kind of a realization of the need for like recognizing early on where clamping is applicable and necessary, and where you should essentially just do it kind of out of the gate, because you're gonna, without it, you're not really gonna get any sort of interesting coverage, and just end up with a coverage report that has a lot of red lines and doesn't find anything really interesting. And it's the kind of clamping that I think could be argued for not being very dangerous, because you're, for like this example, this collateral token, I implemented this get random depositable token, which essentially just it searches the this array of collateral tokens that we have when we're deploying the system, and just uses a random fuzz value. So this will just return us any one of the collateral tokens that will actually work in our system, because the others would just throw with errors like unsupported token, or if it wasn't even a token address, it would obviously throw for that. So yeah, this was kind of a realization of when to. I think it helped me realize what is like, because I think there's a lot of talk of clamping potentially being dangerous, and of course it is in certain contexts, but for things like this, it's kind of, I think, has a relatively high degree of safety and is the kind of thing that will save you a lot of time in debugging your initial, or just getting to coverage initially. So then you can actually start implementing properties, because if you don't, you're gonna essentially just would have to allow the fuzzer to run for probably multiple days or weeks until you actually get any meaningful coverage, which kind of just ends up being a waste of time because you could, in that time, be implementing properties. So, yeah.
Yeah, that's the biggest challenge in also in managing a template. Is effectively, what else could we templatize as part of Recon, and how to do it in a way that makes sense. So it's worth mentioning that when it comes to tokens and actors, we are looking into an enumerable set based approach where you would have a way to add an actor, remove an actor, get the current actor, switch the actor, and the same idea for a token, deploy a new token, set the active token, etc. And it seems to have very low cognitive overhead in terms of how it would work. But that said, this is stuff that just takes time, and you also want to have a direct experience with, simply because you fundamentally don't want to, as Nick said, you don't want to bias your renders. So I guess my true sense on that is that going forward, what we should try more, especially at Recon, is going to be to always have the generic handler as part of our target functions. So maybe that's going to be like, we will have the Recon target functions will be the generic non-clamped handler. And then to that handler, we will add checks, assertions, stateful before, after, all of that stuff, all of the tracking. And then we're going to introduce a separate file with a clamped target functions that would add the clamping, the limitations, etc., as a means to make sure that we do reduce the space when it comes to the API path, but we actually don't reduce the possibility space when it comes to all paths. So that could be an idea. And then the other consideration in terms when instead when it comes to tokens is that fundamentally clamping a token doesn't really mean anything, because at the end of the day, if your setup deploys one token, two tokens, whatever, and it sets it up, especially if you set it up with a relation where you have a deposit token, a collateral token, or a receipt token, etc., then all of your tests are already going to be a consequence of the setup, which is why it's so difficult to formally verify things, simply because you can formally verify a formula, you can formally verify that a system will not overflow, but when it comes to combinations and it comes to the relation between things, then it actually becomes a lot more difficult to specify how things should behave basically one against each other. And so that's kind of something to keep in mind. And so if you're going to fork off of our Eigenlayer or our Renzo setup, what you will want to do is definitely go check the coverage report, see the things that were missed, see the things that you will want to test for. But at the same time, you will be able to start from a much better position, because you would have all of the contracts set up, all of the story moving parts there. And so fundamentally, you will be able to get started from a much better position. So let us know if you end up trying it out, perhaps if you end up finding some bugs with it, or you end up using it in some way. This is not going to be the last ecosystem fuzzing we're doing, but it's also just an experiment in seeing how we can help the community and then developers over time to ship safer code by default by offering them tools that provide them with a level of security. So I think if you have any question, you can drop it in the chat. Otherwise, I think we're gonna call it for today. Thank you for attending our office hours, and have an awesome 4th of July, and I'll see you next Thursday. Have an amazing one. Happy weekend.